ready to start a new unit. This unit is called Stoichiometry, which may be a very new word for you, but we're going to make it look easy by the time this unit is over. So let's go ahead and get started. So we're actually going to start by talking about chocolate chip cookies, which may seem a little bit weird, but working with chemical reactions is actually a lot like cookies. So over here we have a recipe for making chocolate chip cookies. We've got sugar, butter, eggs, flour, and chocolate chips, and it makes 25 cookies. Now, if you know anything about cooking and baking, you have to actually follow the recipe or it's not really going to turn out the right way. So using that recipe, let's answer some of these questions. Number one, it says if you have 6 cups of sugar, how many eggs will you need? So let's focus on the sugar and the eggs. Well, if we have 6 cups of sugar, that is this 1.5 times 4, okay? 1.5 times 4 equals 6. So we have 4 times as much sugar as the recipe calls for. So we're going to need 4 times as many eggs, and so 3 times 4 is going to be 12. So we are going to need 12. That is a tough color to read on this background. Let's switch. 12 eggs. Okay. Number 2 here says if you have 8 cups of flour, how many cookies, rounded to the nearest cookie, can you make? All right, so let's clear off our notes on the recipe because that was a different scenario. Now we're talking about flour and cookies. Well, 2.25 cups of flour, if we're talking about 8 cups of flour, what do we need to multiply by to get 8 cups? Well, this is not going to be exactly even, so I'm going to grab my calculator, which is not where I thought it was. So we're going to take our 8 cups of flour that we have divided by 2.25, and we get 3.55. So we need to multiply by 3.55 to get that 8 cups. So we need to do the same thing to the cookies, times 3.55. So I'm going to do 25 times that 3.55. I'm actually going to do 25 times answer, and I get 88.8. If we round that off to the nearest cookie, that's going to be 89. So our answer here is 89 cookies. All right. Now, this method that we went through over here using the recipe where we have to just multiply by some number, it's a little clunky. If our numbers are even a little bit more particular, this would be a very kind of clunky, outdated way to do this. So we're going to learn a more streamlined way that kind of falls in line with what we've been practicing all year in order to do a calculation like this. And we are going to stop talking about cookies now and kind of relate it back to chemistry because cooking and chemistry is very closely related. So just like chocolate chip cookies have recipes, chemists also have recipes. In chemistry, the recipe is your chemical reaction. So that's going to be something like Na plus Cl2 produces NaCl. And just like recipes, they have to have the right amounts. This is an unbalanced equation here. We see that we start with 2 chlorines, so we need to end with 2 chlorines. So I would put a 2 coefficient in front of NaCl, and then a 2 coefficient in front of Na. Okay? The amounts that we use in chemistry are not cups and tablespoons and whatnot. They are moles. And the ingredients are the chemicals. Okay, so the numbers out front here are kind of like in our recipe. You know, it might say 2 cups of something. For us in chemistry, though, that 2 means 2 moles. And then the chemical formula itself, that's the ingredient. That's sodium. Okay, so I'm going to erase some of my notes here. And if you'll follow along with my, my green dot, I'm going to read this recipe for NaCl. 2 moles of Na, sodium, plus 1 mole, because there's a coefficient of 1 mole of chlorine, produces 2 moles of NaCl. So this equation right here, this balanced equation that we worked on in the last unit, is now our chemical recipe for producing something. All right, so this relationship between different chemicals in a chemical reaction and the numerical quantities is called something called stoichiometry. Now, that word sounds a little crazy, so kind of follow along with the pronunciation with me. Say it out loud wherever you are. Stoichiometry. Stoichiometry. So what it is, like it says here, it is the quantitative, that means numerical relationship between substances in a chemical reaction. And it's all based on the mole ratio. So basically, it's like understanding a chemical recipe. So the mole ratio is the relationship between the coefficients that we have in a balanced equation. So we're going to look at this equation down here with magnesium and oxygen and begin to understand that recipe, that relationship. So the 2 mg here, we would say that that is 2 moles of magnesium because it has the coefficient of 2 right there. This next thing has a coefficient of 1 in front of it. So we would say that this is 1 mole of oxygen. The subscript of 2 is not saying that you have 2 of them, like 2 moles of oxygen. O2 is the chemical formula of oxygen, but we have a 1 in front of it, so that means we have 1 mole of oxygen. And it produces, this chemical over here would be 2 moles of MgO. So our ratio here is 2 magnesiums to 1 oxygen to 2 magnesium oxides. That is called the mole ratio, and again, it came from the coefficients. So mole ratio is indicated by the coefficients in a balanced equation. We have the same example here, 2 magnesiums plus 1 oxygen produces 2 magnesiums. So we're going to try a couple of questions here. The first one, what is the molar ratio between magnesium and oxygen? So we're just looking at those 2 chemicals. So this shows us 2 magnesiums reacts with 1 oxygen. So the mole ratio is 2 to 1, or we could say 2 to 1 that way. The second question, we have what is the molar ratio between magnesium and magnesium oxide? So we're just looking at a different combination here. Magnesium and magnesium oxide. The coefficients are 2 and 2. So the mole ratio would be 2 to 2, or we could say 2 to 2. Now we don't reduce that when we're looking at mole ratios. In theory, you could, but we like to remember where these numbers that we're using came from, and so we want them to match the coefficients. All right, our last example down here, we've got what is the molar ratio between magnesium oxide and oxygen? Well, the magnesium oxide has a coefficient of 2, and the oxygen has a coefficient of 1. So this mole ratio is 2 to 1. All right. Here's another example. I want you to write down the molar relationships represented by this equation here. So this equation is the synthesis of water. Go ahead and pause to try it out. Try to fill in these numbers down here and then press play to check back with me. The mole ratios for these chemicals are simply going to be the coefficients. So 2 moles of hydrogen react with 1 mole of oxygen to produce 2 moles of water. So again, pause here if you need to before you move on. This next one here is just a little bit more practice. We are continuing to see that the mole ratios come from the coefficients in the balanced equation. Now you might notice that this is not a balanced equation, so we need to work on that first. The nitrate has the 3-2 split, so I'm going to put a 2 in front of the aluminum nitrate so that we now have 6 nitrogens, 6 nitrates, that's 2 times 3. And I'm going to put a 3 in front of the magnesium nitrate because that's 3 times 2 for the nitrate, that's also 6. So the nitrate is now balanced, and now I just need to balance the metals. I have 3 magnesiums here, so I need a 3 here, 2 aluminums here, and I need a 2 here. All right. So down below here, we are filling in the mole ratios. So again, these are just the numbers from the balanced reaction. So watch along with the first 2. Aluminum nitrate has a coefficient of 2. So I put a 2 in front of it for the ratio. Magnesium is next, and magnesium has a coefficient of 3. So the mole ratio between those two particular chemicals is 2 to 3. The next one, I have again the aluminum nitrate. It had a coefficient of 2. And next I have the magnesium nitrate on the product side. That has a coefficient of 3. There we go. So we see that we're just pulling the coefficients. Go ahead and pause the video and then check back with me when you have tried to fill in the rest. Okay, aluminum nitrate is a 2, aluminum is a 2, magnesium is a 3, magnesium nitrate is a 3, magnesium is a 3, aluminum is a 2, magnesium nitrate is a 3, and aluminum is a 2. So there are our completed molar ratios. We don't reduce them, even if we can, because again, we want to remember where the numbers came from. Very good. All right, a couple of reminders here for how we're going to do stoichiometry problems. We're going to write the balanced equation. This step number 1 here is crucial. If you don't have a balanced equation, you're going to do these problems incorrectly because you're not going to have the proper mole ratio. Number 2, you're going to determine what starting value you're given. You are going to have to read the question carefully and figure out what is the starting value you are given. It might be a reactant, it might be a product, but number 3, you're going to determine what unit your answer should be in. So you're going to look and see what you're trying to find. And then you're going to set up the dimensional analysis. So dimensional analysis is going to be one of these kind of classic problems where we put what we know over 1, and then we continue on from there. All right, and then you're going to use your balanced equation to plug in your mole ratio. That's going to be the coefficients, and you're ready to go. So your setup is going to look like we always do conversions. It's going to look like this. Now, sometimes we did it with a line and then a multiplication sign and then a line. Sometimes we did it like the train tracks. Either way you see it, it's the same thing. You multiply the numbers across the top, and then you divide by anything that's on the bottom. All right, so let's jump into the first problem here. Number 1 says, how many moles of KClO3 must decompose in order to produce 9 moles of oxygen gas? And the balanced equation is provided. We will sometimes provide that for you. Sometimes we'll ask you to balance it. That's a skill that we learned in Unit 5, but for now, we're giving you the balanced equation. So what we really need to do here is carefully read the question and look for 2 things. What is it giving you the information about? What is it giving you a number for? And also, what is it asking for? This is going to work just like a conversion problem that we've done in the past. And so what it's giving us is 9 moles of oxygen gas. So just like we normally would in a conversion problem, that is going to go in the starting spot right here in the upper left. So I'm going to put 9 moles of O2. This down here is just a 1. Now, just like always, I'm going to take that unit, moles of O2, and I'm going to bring it down diagonal down here. Moles of O2. Excellent. And then finally, we need to, again, go back to read the question and look for what it's asking for. So we look for the question word, how many? How many moles of KClO3? So that's what we're going to solve for here. So moles of KClO3 is what we're converting to. All right, now this is super important. What we're going to is a mole to mole conversion. And I'm going to say this about 8,000 times. Whenever we're converting from moles to moles, we're going to use the coefficients from the balanced equation. And you want to pull the coefficients that go with that particular chemical. So on top, we have KClO3. The coefficient that goes with it is the 2 out front. So that's what I'm going to put in front of it here. And on bottom, we have O2. So I'm going to pull the coefficient from that chemical. The coefficient for O2 was 3. Okay, we cancel out the units that cancel, cross, cross, and now we're ready to do the math. We remember that we multiply the numbers across the top and then divide by the bottom. So this is going to be 9 times 2 divided by 3. So that's 18 divided by 3. So our answer is 6. That's 6 moles of KClO3. That is our numerical answer. But for what we're going to be doing later, I'm going to, again, explain what happened here. The answer we got was our moles of KClO3, and that was a reactant. So I'm going to write a little story here. So our answer was 6. 6 moles of KClO3. What do? They decompose, because that's the only reactant, decompose to form what we started with, 9 moles of O2. 9 moles of O2. Okay, so when you're getting your answer, it's important to think about what does your answer mean. In this case, in order to get 9 moles of O2 produced, we needed to decompose 6 moles of KClO3. All right, great job. Let's try another one. If you want to produce 4 moles of MgO, how many moles of Mg will you need to start? Okay, so what I notice first is that my equation is not balanced. So I'm going to look at my Mg, it's 1 and 1, that's balanced. My oxygen is not balanced. I started with 2, but I only ended with 1. So I'm going to put a 2 in front of the MgO, but then I also will need a 2 in front of the Mg. So I have a balanced equation ready to go. All right, reading the problem carefully, I see that my starting amount is 4 moles of MgO. So that's going to be my starting value in my conversion factor. 4 moles of MgO. That's over 1. The unit comes down diagonal, moles of MgO. And then the unit that I'm going to put up top here is what it's asking for. Where's the question word in the problem? How many moles of Mg? So moles of Mg is what I'm going for. So I'm going to put moles of Mg in my starting amount, in my ending unit spot. All right, here it is. I said earlier, whenever we have moles over moles, what numbers do we use? The coefficients. So the coefficient for magnesium was a 2. Ooh, that's hard to read. A 2. And the coefficient for MgO was also a 2. Okay, so we're going to do the math here. Multiply across the top, that's 4 times 2. Divide by the bottom, that's divided by 2. So that's 8 divided by 2, and that's 4. So my answer is 4 moles of magnesium. Okay, again, if we kind of put this into a thought about what's really happening, what this tells us is that 4 moles of magnesium were needed as a reactant to produce what it gave us to start with, 4 moles of magnesium oxide. That's what the problem had told us. So that's kind of, again, a sentence explaining what happened. All right, next up. If you begin with 3 moles of Al, I'm going to go ahead and point out that that is clearly our given. That's what we're going to start with. How many moles of Fe can you produce? I'm going to go ahead and point out that that is what we are trying to find. I notice that my equation is not balanced. So I'm going to look at my metals first. That's what I normally do. Iron, I see, has 3 on the starting side, so I need 3 irons on the ending side. So I'm going to put a 3 there. Aluminum right now seems fine. I have 1 and 1, so I did my metals. Phosphate is PO4, and I have 2 of them on this side, but I only have 1 on the product side. So I'm going to need to put a 2 in front of AlPO4. And then, of course, I now have 2 aluminums, and I need 2 aluminums on the other side. So I have a balanced equation. I'm ready to roll. So I'm going to start with my given in my starting spot, 3.0 moles of aluminum over 1. I'm going to bring my unit down diagonal. That's going to be moles of aluminum. And what am I looking for? I'm looking for moles of Fe. So moles of Fe is going to be up there. All right, this is the classic scenario. This is our new thing. When you have moles over moles, what numbers do you use? You use the coefficients. So the coefficient that goes with iron is a 3. So that's going to go on the top. The coefficient that goes with aluminum is a 2, so that's going to go on the bottom. That one was pretty easy. That's it, y'all. So we're going to multiply the numbers on the top. So we have 3 times 3 divided by the numbers on the bottom, which is a 2. That's going to be 9 over 2, which is 4.5. So my answer here is 4.5 moles of Fe. And I'm going to go ahead and just write in the word produced, because what we solved for was a product. Instead of writing out the whole sentence like I did on the previous examples, I'll just kind of simplify it with one word. 4.5 moles of iron will be produced. Okay, let's try another one. NaCl will react with F2, that's fluorine, to produce NaF and Cl2. First step, write the balanced chemical formula for this reaction. So here we go. NaCl reacts with F2 to produce is going to be an arrow, NaF and Cl2. So now we need to balance the equation. I see that my F and my Cl have 2, and so I need to make 2 chlorines on the left-hand side. Chlorine is now balanced. 2 fluorines on the right-hand side. Fluorine is now balanced. And sodium took care of itself. Sodium is now 2 and 2 on both sides. Looks like we're good to go. All right. The question here says if you have 3.25 moles of NaCl, that I'm going to label that right now as my given, how many moles of F2, that's what we're looking for, that's our unknown or our find, will you need to completely react with it? Okay, so we start by putting what we know in the upper left. 3.25 moles of NaCl. That unit comes down diagonal, moles of NaCl, and what we're looking for is moles of F2. That is my unknown. Okay, I'm going to plug in numbers here on the mole-to-mole ratio with the coefficients. So fluorine F2 has a coefficient of 1, and NaCl has a coefficient of 2. So that's going to be 1 on top for the fluorine and 2 on bottom for the NaCl. My moles of NaCl cancels, and so my math works out to be 3.25 times 1 divided by 2. I'm going to go ahead and let's pull up our calculator. 3.25 divided by 2 is 1.625. We'll round that. It's 1.625 moles of Fe. My final task here would be to consider sig figs. 3.25 is only 3 sig figs, so I only want 3 in my answer, so I'm going to cut it off there. So I'm going to go ahead and report my answer here as 1.63 moles of Fe. All right, so we did it. 1.63, very good, y'all. All right, if you're here at RHS, your homework will be the first worksheet in your notes packet that will say mole to mole practice. The main idea that you can remember here is that whenever you have a mole over mole conversion, what numbers are you going to use? The answer is you are going to use the coefficients. So the coefficients you're going to put there, and you'll be good to go. Thanks for watching. Hope this was helpful. Let us know if you have any questions. Have an awesome day.